This is lesson 106 mini lecture, and so in this one you're just learning more about roots of polynomials. So I don't know if I ever shared this with you before. I think I probably did. Here's x squared, here's x cubed, x to the fourth. So I think one time I told you guys whatever that is, it'll have, like whatever the exponent is, it'll have one fewer turns or one fewer like curves in it, right? I think I said that to you guys before. Here's x cubed. Okay, and here's x to the fourth. Actually, x cubed, I want to make it look a little different. I want to make it go like this. Okay, so x squared, we'd expect it to have 2 minus 1, that's one curve in it, right? X cubed would have two curves in it, right? Or two turning points. X to the fourth would have 3 turning points. Well, it turns out you can count their zeros as well. X squared can have up to 2 zeros in it. Okay, x zeros meaning roots, you know, places where it crosses the x-axis. Those are real roots when they cross the x-axis. We'll talk about complex roots as well. So x cubed could actually have up to 3 roots, right? So if I was like, I don't know, factoring this thing and using the zero product property, I could get like 3 different answers for that. That's a quadratic, so I'll get 2 answers. This would give me three roots. This could give me up to 4. 1, 2, because that's how many times it could possibly cross the axis. But sometimes, you know, sometimes it doesn't even hit the axis. Like a parabola could just hit the axis once and only have 1 root, or this parabola could hit it could never hit the x-axis. Maybe it's like that. Maybe it has, that's when it has, you know, when you use the quadratic formula and you have imaginary numbers, like your discriminant is negative. That's, if you graphed it, that's what that would look like. It would look like it didn't cross the x-axis. This one would be when you have a root with multiplicity of 2. Okay, so this thing could actually, if it's x cubed, right here, see where it just barely touched the axis, that would have a multiplicity of 2, because it just barely touched it. Or it could go like this and just only have 1 root. It could have 1 real root and 2 imaginary roots or complex roots. Same thing here. It could, you know, it has up to 4 roots, but maybe it goes like this, and then maybe it goes something like that, and maybe it has 3 real roots or something, and then so I think that's kind of what this is saying. When I say roots, I mean like zeros, places where they cross the x-axis. And so there's some pictures in here. See, 2 distinct roots, 2 identical roots. That's when you have a multiplicity of 2, and that has 2 complex roots. Oh, I forgot to tell you that the roots, they can be complex. Okay, so when I was talking about how many roots, I was talking about real roots. These are real roots. So this could have some real roots and complex roots. Hopefully I made that, you understood that when I said that. So how do we find the roots? Well, we factor it and use the zero product property. So basically, you know, sometimes you have to use the quadratic formula, but usually you can factor these things. Set them, you know, set the thing equal to 0. In this first one, we're going to actually use some synthetic division on it. And then we're going to use zero product property, and we're going to find some roots. So remember, if you're trying to factor a cubic or solve a cubic, you just want to try 1 and -1 first, and then I'm grabbing the coefficients off of the terms that are in descending order by exponent. Okay, so try this. 1 times 1 is 1. You add these and you get 2. 1 times 2, 17. That's -15. Oh, lucked out. You almost always luck out if you use 1 or negative 1. See how I got a 0 here? So this can be written as x. Oh, I messed it up. That's gonna be x minus 1. I give you x minus 1. This can be written as x minus 1 times. This gives me an x squared and an x. So that'll be x squared plus 2x minus 15. Set that equal to 0. I already found one of my roots. There's a root at x equals 1, or a 0. I should say a 0. Right here, I will try to do a diamond problem on it and see if I can get some more. So this is negative 15. It has to multiply to make negative 15 and add to make 2. So what two numbers could possibly do that? 5 times 3. So it could be a negative 3 and a positive 5. So this is going to give me x equals 3. Here's my roots, and here's x equals negative 5. Okay, so what was I asked? Let me solve the following equation by finding all the roots. There's my 3 roots. Get it? Okay, I'm not going to do all of them. I think you guys will be able to do some of these. I have time to do I'm going to do letter D. Letter D, probably need a new piece of paper. Letter D is a quartic. So we're going to have to pare it down. So by paring it down, I'm going to, try to use my synthetic division trick on it and see if that works. I hope it works the first time. 1 times 1 is 1, negative 7. 1 times negative 7. And 6. Is that 22? That didn't work. So try negative 1. Okay, now it's time to use the, what do we call that? The rational root theorem. We want to make sure that I don't try using something that it couldn't possibly be. 2 goes into 30 and it goes into 1. It goes into 30. So that would, I could try 2 and I could try negative 2. I actually know that 2 and negative 2 aren't going to work, so I'm going to go skip over to 3 just to save time on this video. You might have to do stuff like that. You're going to have to try multiple times. Now 3 goes into 30, that's why 3 could be a candidate. Now if 3 doesn't work, I'm going to try negative 3. There's 1, 3, 3, negative 5, negative 15, negative 2, 10, and there's 30. So I kind of cheated. I really didn't know it was 3. I kind of looked in the answer book and I saw that I should probably skip 2, and you guys already know how to do synthetic division. So okay, so I got this. So now that means it's going to be x minus 3 times, this is going to be, I started with a quartic, so this is going to be cube, square, and then x, like that. So it's going to be x cubed minus 5x squared minus 2x plus 10. I'm going to continue this on the next video because I'm running out of time.